Well, hello and welcome to today's webinar, using multispectral imaging to boost crop health from data collection to analysis. So this is our second in a series of Harris webinars, and today my name is Nigel Brown. I'm the moderator for today's webinar, and for those of you that are new to Harris Geospatial Solutions, I wanted to let you know we're the leading provider of software products that extract meaningful information from all types of remotely sensed data. And over the last 30 years, we've built a reputation for being the leader in both hyperspectral and multispectral data analysis through our flagship product, ENVI. We also, with an in-depth knowledge of geospatial analytics and a highly tuned process for applying machine learning technologies, are able to deliver game-changing enterprise-level solutions across industries. Our latest offerings include high-resolution Geiger mode LiDAR capabilities, an online geospatial marketplace where imagery and data-derived products can be procured. I'm delighted that so many people are able to join us today from both continental US and from Europe, and especially to our two presenters calling in from Seattle, Washington. I'm delighted to introduce Drew Boschan. Drew is the Business Development Manager at MicaSense. So Drew has been on the sales team at MicaSense for the last 2 years. He's primarily involved in developing new and existing markets around the world for selling the MicaSense RedEdge M multispectral camera and other products from the MicaSense range. Drew's past experience includes sales at a major ag tech company, as well as technical specialist at a precision ag dealership. And Drew holds a Bachelor of Science degree in Agricultural Science from Cornell University. So Drew, thank you very much for joining us today.
Yeah, thanks for the introduction, Nigel. I appreciate it.
Great. I wonder whether, for those that are new to MicaSense, whether you could just give us a quick intro to MicaSense also.
Yeah, absolutely. So MicaSense was founded in 2014. Since then, we've developed 3 or 4 different cameras, different multispectral cameras. Hardware development is our focus. The most recent product release is the RedEdge M, as you mentioned before. We're really proud of to be able to say that we have cameras in over 60 countries around the world. So I like to say that we're arguably the standard when it comes to drone-based multispectral imaging.
Great, thank you very much. And also joining me here in Broomfield, Colorado, Austin Coates. He is the product manager and technical lead for our ENVI Crop Science and Precision Pass products. And Austin has a background in vegetation mapping and monitoring. In the past, he's worked on projects ranging from monitoring and mapping palm oil plantations for the Environmental Protection Agency here in the US, and has also been involved in helping correlate forest biomass and ground topography for NASA Jet Propulsion Labs. In the vegetation mapping space, he's also authored several papers for the Remote Sensing of Environment and Remote Sensing journals. So welcome, Austin.
Thank you very much, Nigel.
Great. So before we get into the detail of the webinar, we have a few housekeeping items that I wanted to run through with everyone. We've got a lot to cover today, so I'll keep this relatively quick. We've muted all of the phone lines for all attendees. That just cuts down a lot of background noise and interruptions. And we obviously want your interaction in this webinar, and so we encourage you to ask questions by entering your questions into the questions box that you'll see in your panel. If you can put those in throughout, we will keep an eye on those, and we'll cover as many questions as we can at the end of this presentation.
Somebody's saying that we can't hear the audio. Do you want to do a sound check?
Yeah.
Ask other people if they can hear you.
We have one person saying troubles with the audio. Can anybody confirm online, if you put into the chat, whether you can hear me? Okay, we're getting a bunch of good hears, so that is good. So sorry for the person that's having troubles. Maybe it's related to your own computer itself. You could try logging back in, or even using the dial-in, which was in the email that was sent out to you. There's the ability to just use a telephone dial-in to hear the audio on this. So thank you for putting that in. In addition, we will be encouraging your interactivity with the event by conducting 4 simple interactive survey polls. We invite you to participate in each and every one. Good news for those, if you are having troubles hearing this, you'll be glad that we will be sending you a recording of the webinar as well as a copy of the slides in the next 24 hours. So you'll see links to that you can use for yourself to review and also share with colleagues. So to get things going, let's start off with a poll question. So the first poll question is, what best describes your role? And there are 5 options. We'd like you to select A, B, C, D, or E. Either you're a grower, an educator or a researcher, or a service provider, or you may be a systems integrator, or you may be categorize yourself in another area. So we're going to close the poll off in about 10 seconds. If you can make your choices now. Okay, we're going to close the poll down. And let's have a look at the results. Okay, it looks like we have a good mix across the board. 35% service providers, 37% educators and researchers. We have 5% see themselves in the grower category, and 18% as integrators, just 5% other. So we're really good to know that we can focus in on the service provider, the researcher, educator area. And I think you'll see great value throughout this webinar. So thank you for that participation. And we will move into a brief overview of what we're trying to do today. So the goal of today's webinar is to take you from data collection to information discovery, and along the way, introduce you to the power of the MicaSense RedEdge multispectral camera and the capabilities of the ENVI tools for precision agriculture. And the idea is to take you through that process from collection, making sure that we share with you ideas and thoughts around how best to set up and calibrate your camera, when you're flying your data, how to use some of our tools to make sure that you've got a good, solid collective data before you leave the site. Then back to the office, you may then want to be going through the process of bringing all the imagery together. We have tools to help you create very high quality orthomosaics. And that then enables the data to be science ready for the in-depth analysis that we can do in our ENVI Crop Science tool. And it's from that analysis that we really then start to discover meaningful information from your data. So that's the flow that we want to take you through today. And we'll do that by having Drew start talking about the RedEdge sensor itself. So Drew, back to you.
Yeah, thanks, Nigel. So yeah, I'm going to cover a few value points on the RedEdge and multispectral kit. So it's a 5-band multispectral sensor that integrates with almost any drone, as long as the drone can carry the weight of the 173-gram camera kit. And if you can supply some form of power to the camera, it's really versatile in terms of drones that it can integrate into. Another thing is that with the data that's collected, those 5 spectral bands, you have the ability to generate multiple different vegetative indices and composites. And one of those composites is the RGB image, the RGB composite. So if you're a service provider who's interested in collecting multispectral imagery and you also want an RGB output, that is possible with the RedEdge M. Another thing is the data that's collected with the camera. It's either a 12-bit TIFF or a 16-bit TIFF file. The way that you can extract the metadata from that file is documented very well on our knowledge base, where we try to be very transparent when it comes to the information that you're collecting, the type of data that you're collecting, the metadata that's in the files themselves. And related to that, the data that's collected can be processed in many different platforms, so you're not pigeonholed into one particular processing solution. Another thing is that with the camera kit, we provide you with the hardware components that allow for radiometric calibration for analysis over time. And we'll talk more about what the radiometric calibration means and why that's valuable in a few minutes. But one of the components you can see on the screen here on the lower right-hand side is the downwelling light sensor. And then we also send a calibrated reflectance panel that you'll see a picture of in a few minutes. Another thing that's valuable about the camera is it's rugged and reliable. So there are no moving parts in the camera. We've had at least 2 or 3 instances of our users crashing the drone, obliterating the drone, and the camera powers up and operates just fine afterwards. Now, it's not a guarantee, but it's fun to tell those stories. Next slide, please. It's an easy to use camera. On the back of the camera, on the aluminum backplate, are embedded mounting points, screw holes for quick integration. If you're fabricating your own integration for a particular drone, those screw holes can be very handy. There are also available integration kits that MicaSense offers. And if you can't find a particular integration kit from MicaSense directly, I'd recommend that you go to our partners page and look up our partners who have made integration kits themselves for specific drones. And they also provide complete drone solutions. When it comes to setting up the camera for operation, there's a Wi-Fi interface. So imagine that you're out in the field, crouching down next to the drone and the camera, similar to the guy in the picture, and you power up the camera. The camera sends out a Wi-Fi signal that you can connect to on a phone or a tablet. And at that point, you can access the web app of the camera, where you set up the camera for either timer or overlap mode for image collection. Powering the camera, as I mentioned before, it's either done through pulling power from the drone directly, or you can add an auxiliary power supply to the drone to supply power to the camera. Probably the majority of our customers are pulling power directly from the drone. When it comes to extracting the data that you've collected at the end of the flight, we have an SD card slot on the side of the camera where the data is being written to. So when you're done with the flight, you just remove that SD card and take that data wherever you need to. So the 5 spectral bands that we're capturing on the RedEdge are blue, green, red, RedEdge, and near infrared. And another characteristic of these bands that are beneficial, not just because we have 5 of them, but also because of their bandwidth, is very narrow. And that allows for more precise data collection and measurement of a plant's health. And I'll try to explain that here. So on the right-hand side of the screen, we've got a graph that's showing you percentage reflectance on the y-axis from 0 to 50%. On the x-axis, we've got a portion of the light spectrum in visible. We've got the visible light portion of the spectrum, and then we've got non-visible light on the x-axis. Inside of that graph is a green line that represents the reflectance of a typical plant. So if we start on the left side and work our way over, you see that blue reflectance is very low. Plants absorb more blue light than they reflect. At green, it jumps up a little bit. We see there's higher green reflectance. We can see this when we go outside in the summertime and we see most plants as green because most of that visible light is getting reflected back into our eyes. And then it drops down again at red. Plants typically absorb a lot of red light for photosynthesis, so there's not a lot of red reflectance going on when a plant is healthy. And then we get past visible light and the reflectance increases quite a bit through RedEdge and then into near infrared. So keeping that plant's reflectance profile in mind, the ways that it interacts with reflectance at different positions along that profile. When we have narrow spectral bands, specifically blue is 20 nanometers, green is 20 nanometers, red is 10 nanometers, and RedEdge is 10 nanometers. When we have these very narrow bands, we can position them in strategic places along the plant's reflectance profile that are going to allow us to pick up small changes. For example, changes in a plant's photosynthetic activity is going to be identified by a change in reflectance at red. Whereas if you're using maybe not a professional grade multispectral camera like the RedEdge, maybe you're using a converted camera that has a modified filter in it, you might be capturing much wider bands. So that's illustrated on the left-hand side of the screen, where we see at red, we see a band that's much wider than the 10 nanometer wide band of the RedEdge. Sometimes they can be anywhere from 50 to 150 nanometers wide. And the important thing to note about that is that you're not just capturing data at red, you're capturing reflectance data at other portions of the light spectrum that might not be critical for determining variability in that plant's health. So that's really the benefit of the narrow spectral bands, is just precise data at the correct positioning. So the next thing is radiometric calibration. So radiometric calibration is important in this respect. So imagine that you're out flying a particular field today, and it's a clear sky, there's not a cloud in the sky. And then 2 weeks later, you want to see the changes that have occurred in that crop from today to that, from your previous flight 2 weeks ago to the current flight. But the lighting conditions have changed from the first day being sunny to the next day being overcast. So you can't make an accurate comparison of the first data collection to the second data collection because the lighting conditions have changed. In order to remove the bias of that lighting condition, we need to radiometrically calibrate the data. And we do that by first using this calibrated reflectance panel that we send with the camera. So you lay that on the ground in an area that represents the lighting for that particular day. You take a picture of it with the camera before the flight, and then we use that calibration shot in processing to radiometrically calibrate. So another component that we include with the kit is this downwelling light sensor. So this is mounted on top of the drone, and during the flight, the downwelling light sensor is capturing lighting changes and writing them into the metadata of each file, each image that's captured. So we use the calibrated reflectance panel shot and the DLS data in conjunction with each other to radiometrically calibrate the data, which enables time analysis and use of agronomic models. It just makes your data more insightful, essentially. So in addition to the narrow bands and the ability to radiometrically calibrate, the other benefit that's sort of obvious of the RedEdge is that we're capturing 5 bands. So with those 5 spectral bands, we're allowed to not just generate an NDVI map, but we can generate other indices as well. One of those indices in particular is NDRE. So NDRE is generated using RedEdge and near infrared, whereas NDVI is generated using red and near infrared. And the benefit of having NDRE and other indices that are similar to NDRE is generating a map that shows you variability in chlorophyll content, or a more highly correlated map showing variability in chlorophyll content, whereas an NDVI image is more closely related to a plant's biomass and vigor. So typically basically what the value is here is you see an NDVI image of your field and you might see some characteristics, but if you see an NDRE image of your field, you're going to pull out other characteristics of that crop that you wouldn't know if you were just relying on one index. So basically the benefit of having multiple indices just gives you more insight into what's going on in your field or your test plots or whatever applications you're doing.
Okay, so that
Nigel, go ahead.
Yeah, sorry, that takes us into our next second poll question that we'll have Drew comment on afterwards. So poll question number 2, what is your experience level with agricultural drone imaging? Whether it's very little, you don't have a drone yet, more of a beginner, you're still learning, you have a drone and you fly with a stock camera. You've got to classify yourself at the intermediate level, flying frequently, exploring different payloads, or consider yourself an expert, flying with different drones with many different payloads. So those are the 4 options. We'll give you 5 more seconds. And Drew, I'm curious, you should be able to see the results of these polls remotely, is that correct?
Yeah, I can.
Great. Okay, so I'll let you comment. We're going to close the poll down now.
Okay. Yeah, that's actually kind of what I was expecting from this audience, given that most of you are academics or service providers. So intermediate, fly frequently, exploring different payloads, 39%. I feel like that would be the accurate profile for someone who's in research, who's experimenting with different payloads, maybe thermal, maybe multispectral, maybe even hyperspectral. But it's also good to see that we've got some beginners. Maybe you have a drone flying with a stock camera. That's typically how people eventually get into the more complex systems, like a RedEdge multispectral camera. You start with a RGB imager, and then you want more functionality, and you upgrade. So this is great to see.
Excellent, thank you. And I see lots of good questions coming in through the questions box, so keep those coming. We will, as I said at the beginning, we'll cover those all at the end. But thank you for the participation here. Back to you, Drew.
Mm-hmm. Yeah, so next we'll go through a few pretty elementary slides on data collection and things to consider. This is probably going to be good for the first two categories of our poll results. So the first thing you want to consider before you collect data is the lighting conditions. So really the best kind of conditions are consistent conditions across the area that you're collecting data on. That could be either a clear sky like you see in the lower left-hand side of your screen, or in the central portion, a uniformly overcast sky. The uniformly overcast is probably even more desired than the clear sky, but really what you want to avoid are severe changes from shadow to sun, like you'll see in a cumulus cloud situation, kind of like what we see on the right-hand side of your screen. That's going to create sharp changes in light to shadow that are too extreme to completely eradicate in data processing. So sometimes it causes anomalies in your data. So another thing to keep into consideration is defining a mission. Probably most everyone on this call knows that if we're collecting data, it's going to be with an autonomous mission. We're not going to be doing any manual flying. So when we set up the grid for the mission, the first thing to keep in mind is we want to make the grid a little bit bigger than the area that's being collected, so we have a uniform orthomosaic as an output. So in this image, we see the green rectangle as the area that's being covered, and the red is representing the passes of the drone across that area. So you can see that the turnaround points are beyond the field, and then the first and last passes are also beyond the actual area that's being covered. So if we start over on the lower left-hand side and we're flying along, we start that mission, all those black dots are image collection events. Basically, the camera's triggering and it's capturing images at that point. So we're flying along, the camera's triggering. This first vertical arrow up and down is just a terminology thing. So front lap is what we call the overlap that's occurring between two images that are captured on the same flight path. And then we fly up to the top and we cross over again. We come down for the next flight. Before we do that, you see that vertical line, or horizontal line, excuse me, that's representing side lap. So side lap is the distance between two images that were captured on separate passes. And that'll help you understand the next slide. So we recommend capturing minimum of 70% front lap and 70% side lap during data collection in order to set yourself up to create a high quality output. And I think Austin is going to be talking a little bit more about this one in the next few slides, but this is just a visual of kind of what that would look like. So we're capturing data, and you see that there's quite a bit of overlap, 75% overlap on front lap, and then we come back and there's 75% overlap on side lap, or 70% minimum. And with that, I think I'll pass it over to you, Nigel.
Yeah, Thank you. That's great. And the questions keep flooding in. Obviously, you're getting a lot of thoughts going here, so thank you.
Great.
So
Great.
we're going to do poll question number 3 now. So what problems are you most frequently using imagery for? Are you looking to identify crop stress? Are you counting individual plants or trees? Are you focused on yield estimates, identifying and monitoring disease, or all of the above? And as I read this out, maybe we should have had F of none of the above. But we'll give you a few minutes to, or say a few minutes, a few seconds to put in your answers, and we'll close the poll down, and we'll have Austin comment on the outcomes there.
All right. So looking at the results from the poll, it's overwhelming all of the above. That's exciting to see. We also have kind of a nice distribution between identifying and monitoring disease, yield estimates, counting individual plants, and identifying crop stress, which is great. We'll go over a lot of that in the next section. All right, so kind of a look ahead. This is what we're going to cover, and you can kind of start to think about these things as we go through the next slides. So beginning with Precision Path, this is our field validation tool. So using the MicaSense RedEdge, when you're out in the field, you've just collected your imagery and you want to make sure that it's ready and all valid so that later on you can do your orthomosaicing. Precision Path is a great solution for this. You can then take those results, bring them back to the office, pass them through ENVI, and do image-to-image registration. So with the MicaSense RedEdge, each one of the bands is captured by a different camera, so it's important that you do image alignment, and so we can help with that using ENVI. And then using ENVI1 button, you can do orthomosaicing to get a final image that can either be visually interpreted or passed into ENVI Crop Science for further analysis. So this is Precision Path. This is our field validation tool. This doesn't require internet connection or any kind of connectivity at all. It runs on a Windows laptop out in the field, and it's designed to quickly give you the results from your image capture. So we want to make sure that when you're out in the field, you realize if you had a problem or not, so that you don't have to go back to the office, find out, oh no, I left the lens cap on or something crazy, and then go back out to the field and capture again. On the left-hand side of the screen, we can see the user interface. So you have a couple of different views. Right now, I'm showing the image overlap. So this is just kind of a visual representation of what has been captured. The tool can take in both imagery with IMU data and without IMU data. So in this example, we didn't have the IMU turned on. So we're interpolating the yaw throughout the capture so that you can see the final results here. And then on the right-hand side of that user interface screen, we have all those green check marks. Those are looking at things like saturation and contrast, as well as different characteristics like Drew was talking about. So ground sampling distance, your GSD, or say your forward overlap or your side overlap. And then on the right-hand side of this slide, we have two different views. So you can see your flight lines and how they were collected. That's that black line overlaid on the blue polygons. And then in the lower portion, we're looking for 70% overlap in this image. We were right on the cusp, but we weren't quite at that 70% mark. And these little red polygons indicate which tiles didn't quite achieve the 70%. It was just perfect for our uses here, but it wasn't quite at that 70% mark. All right, this is a visual of the UAV toolkit. So this is free software that we distribute through our GitHub account. And what this does is it does image-to-image alignment. So on the left-hand side of the screen, you can see the blue, green, near-infrared, RedEdge, and red frames. So these are the 5 frames that will come back from the MicaSense RedEdge camera. And then they all need to be co-registered or aligned to one another so that you get a final kind of image stack coming out of it. This result here on the right-hand side is a bit of PowerPoint magic, but it's just to get the point across that when you line them all up, they don't just line up perfectly. So there's quite a bit of image registration that has to happen. But this image registration. Oh, sorry. Go ahead, Drew.
Yeah, I was just gonna, compliment this and just say this is a really big deal. A lot of our researcher customers have been asking for this kind of tool. The ability to align single image captures from the RedEdge. So if you're a researcher on the call and you're looking to analyze small plots and you really just want to look at single images and align those, then this is a great tool for that. Sorry to interrupt, Nigel, or Austin.
Oh, no problem at all. Yeah, that's a great point. Yeah, and it's also, so any of the results from any of these steps can be used as a final product. So if you were to just use Precision Pass, you could quickly look at your imagery and assess whether or not you captured the correct things, or even just get a quick qualitative assessment. From this tool, the output, you could just like Drew said, use those single frames and do a single frame analysis. You could take the results, pass it into ENVI or something else to look at them. And so taking the results from the ENVI UAV toolkit, we can then pass them into ENVI One button. So this is our orthomosaicing software. There's two different versions of One button. There's the professional version, and then there's the base capabilities. Both of them will give you a beautiful orthomosaic on the other side. The professional version just gives you a couple more tools to help get that crystal clear image. All right, now kind of the part that I'm excited about. So using ENVI and ENVI Crop Science, we're able to do further analysis on the beautiful multispectral imagery that the MicaSense sensor provides us with. So looking at these results here, on the left-hand side, we have a true color orthomosaic. So this is simply just an RGB image of what the field looks like. On the right-hand side, we have a vegetation index. So this is the green chlorophyll index. And just looking at a little bit of visual analysis here, we can see by that tree in the lower portion of the image, kind of right in the center, there's a little bit of red color there, as well as in the upper right-hand corner. So this kind of tells us that there might be something going on. The field isn't consistent all the way across, so maybe this is an area that we would need to go take a closer look at. Also, in the bottom portion of this slide, you can see that there's two boxes, kind of I don't even know what color that is, greenish, bluish color, and then a yellow box. So this is a representation of the ENVI Crop Science model. So in ENVI, we have this idea of creating models. So with this one, it's a super simple model to create. You simply take your raster and then you would pass it through the Spectral Index tool. Once again, we're using the green chlorophyll index, and then you get your result on the right-hand side. I also want to call out Brant Farms. This is the farm that was able to provide us with this imagery, and thank you very much for helping us out with this. All right. So taking this imagery, we can take it one step further. Instead of just using the simple index, we can then pass it into the hotspot tool. The hotspot tool takes everything in and it groups it together. So the red portions get grouped together, the green portions get grouped together, and then those yellow portions do as well. So green represents anything that is above the mean of the field, and red is anything that is below the mean of the field. So this is a really nice tool because you don't have to be an imagery expert. You can simply look at your image and quickly identify, okay, I've got some red regions, let me go out and take a look at them. Or I've got some green regions, those are producing really well, and maybe I need to do something to mimic the results from those green regions. Another kind of nice portion of the hotspot tool is within ENVI. This is classified as a classification image. So these are all grouped together and they get ready for further analysis. So you can derive statistics on each one of those regions to give you a little bit more in-depth information. All right, so the next portion, we're going to look at how this kind of changes over time. So if you were to take this field and look at the beginning of the season compared to the end of the season, we can see changes. So the way that you'll interpret this imagery is we have a baseline. So this is kind of the mean line of the entire field. This will be everything that shows up in yellow. Anything that shows up in green has you can think of it as a steeper slope. So from time 1 to time 2, the green regions are photosynthesizing at a much higher rate than the mean value of the field. Anything that shows up in red are the regions that are not producing at the same rate. So let's take a look. So early in the season, you can see in the upper left-hand portion of this slide, we don't have full canopy closure yet. Our plants are still just kind of developing, getting their leaves on. And then in the bottom portion of this slide, over on the left-hand side, you can see that we have nice canopy closure. Everything's looking nice and healthy. And then on the right-hand side, we have the developing hotspot tool. So this takes in, once again, you can look at that model in the lower right-hand portion. You see that we have two raster images, early in the season, later in the season. We pass those through the green chlorophyll index, and then we put both of those results into the fine developing hotspot tool. And so once again, the red regions are anything that's not producing at the same rate as the mean. So the mean line, you're expecting your whole field to kind of green up at the same rate, and these red regions aren't greening up at that rate. Whereas the green regions in this image are actually producing above the mean. So these are the portions that are overachieving. So they're kind of the best regions, you could think of it. And like I said before, kind of teased that, you can pull statistics out from these red and green regions so that you can go a little bit further into depth. From that poll question earlier on, we saw that there was a lot of researchers on the phone, so this part might be extra interesting to you. So using ENVI Crop Science, we can then pull the spectra out from those red and green regions, as well as the mean region if you're so interested. And then you can analyze that, comparing it side by side. So over on the left-hand side of the screen, we have the green regions, and then over on the right-hand side of the screen, we have the red regions. That solid line, that represents later in the season, and the dotted line represents everything earlier in the season. So if we compare the dotted lines of the red regions and the green regions, we can see that they're pretty similar. However, the depth of these absorption features in the red and blue are quite a bit deeper, as well as this reflectance in the near infrared is a little bit higher. We can look at it for later in the season as well. So with vegetation, your changes in spectral characteristics are very subtle. So for example, this red region, you can see this absorption feature right here. It's just a little bit above this absorption feature right here. And that indicates that those plants aren't photosynthesizing at quite the same rate as these green regions are. So taking this into account, you can start to build models and other vegetation indices or any kind of statistical calculations that you want to compute based off of this information. So in the image that we saw earlier, we had a little bit of problems in that lower portion of the field and the upper right-hand portion of the field. Once again, we had ground truth over this Brant farm, so we were able to actually find out that this was a potassium deficiency. So knowing that information, we can then build further models based off of the spectral characteristics to look for those sorts of indicators earlier in the season, in the hope that we can catch these things much earlier and then make changes going throughout the season. Bringing it kind of back to a more physical representation, we can see here on the left-hand side of the screen, these were regions that were in those kind of like bright green portions of the field. So this is nice, happy vegetation. And then on the right-hand side, we have a change in pigment, and we can see that these are kind of the regions that are having some of those potassium deficiencies. So I'll turn it back over to Nigel now.
Great, thank you, Austin. My apologies for folks if you saw a dialog box come up on the screen. We had an indexing problem with ArcGIS. But let's move on to the final poll question for today. And really what we wanted to do was get an understanding as we went through this process, what areas particularly piqued your interest? Was it the MicaSense RedEdge sensor, the precision pass tool that Austin talked about, the UAV toolkit, ENVI One button, or ENVI Crop Science? And this is multiple choice, so you can actually select multiple entries there. So we'll give you a few minutes to think about that. Did I say minutes again?
Yeah.
Let's make it a few seconds. Okay, we're closing the poll. Great. Okay, so we have very high interest in obviously both the sensor itself, 53%, and the ENVI Crop Science tool, 69%. Certainly good interest also in Precision Pass and the UAV toolkit and ENVI One button. I know a lot of you will use other tools for mosaicing, and that's just great. But we are proud to be able to offer an end-to-end solution here for you if you need it. So that closes the poll, and we move on to our Q&A session, and you can continue to add questions in there. Just before we go into the questions, I wanted to thank MicaSense for two reasons. One, for putting on such a great webinar with us today, but also for being one of our gold sponsors at the 2018 ENVI Analytics Symposium. And if you enjoyed the overview and the introduction that we gave in this webinar, we will be conducting with MicaSense a 3-hour workshop based on the tools and workflows that are used in this webinar. And as participants of the webinar, we will be sending you a discount code for you and your colleagues to use to save on your registration fees for the ENVI Analytics Symposium, which, as you can see, is being held in Denver, Colorado this August 21 to 23. It's a great thought leadership event. But let's get on to the questions, and we will take as many as we can. How are we doing time-wise? We've got about 15 minutes, so that works out quite nicely. Okay, first questions for you, Drew. Two that are probably related. What NIR band is captured, and what specific band numbers do you use?
Yeah, sure. So the NIR band is should be 840, and it's 40 nanometers wide. RedEdge is at 717. Let's see, red is at 668. I think green is at 560, and then blue is at 475. So 475, 560, 668, 717, and then 840.
Great, thank you.
And you can also, if you go to support.micasense.com, there's an article that basically lays it out. So if you're wanting to get those numbers specifically, you can go there and find them.
Great. Another one for you. Must be an existing customer of yours. When will I be able to customize the bands on the RedEdge?
That's something that we're looking into. We had been offering custom band cameras maybe a year ago, and then we got away from that just because there was so much interest in the standard filter RedEdge. But it's something we're still considering internally. I don't know if that's probably not a very satisfactory answer, but that's all I got right now. Okay.
Well, that's the answer that we have for today is fine. Thank you.
Yeah.
Are there possibilities with Agisoft for calibrating radiometrically? With Pix4D, this is the case. I guess both of you might be interested in this question.
Yeah, I can kind of talk to it. So I can't speak directly to Agisoft, but I can talk to ENVI One button as well as the ENVI UAV toolkit. So those both have mechanisms for taking in calibration panels. With ENVI, kind of our history is in satellite imagery as well as airborne and UAV imagery. So we are very comfortable calibrating any kind of imagery to a scientific level in which you can do analysis on further down the road.
Okay, Drew, I don't know whether you have any experience with Agisoft, whether you know the answer to that one.
Yeah, we have some experience with Agisoft. There are a number of customers who use Agisoft to process. I believe they have a radiometric calibration process in their most recent firmware update or software update. But that's another one where we have a tutorial on utilizing Agisoft on our website. If you go to support.micasense.com and search Agisoft, I think that resource comes up.
Great. Okay. Another one on the camera. What is the maximum shooting speed of the camera?
The camera can take pictures up to 1 per second, one image. So like the camera will fire, all 5 imagers will fire up to 1 image per second.
Great. Gosh, lots of questions. Does the survey grid have to be a down and back, or can we use a moving box grid? We get better performance from the UAV with a moving box grid.
That's like a mission planning question, sounds like.
Yeah.
Yeah. I'm actually not familiar with a moving box grid.
Okay.
So I can't answer that question.
All right, we'll take that offline and follow up with them afterwards. No problem.
Okay.
Alyssa says she works in Georgia, USA, where we frequently have clear conditions at the beginning of the flight, with clouds popping up in mid-flight, leading to anomalies in the imagery. What post-processing methods are available for addressing these anomalies?
Yeah, it gets pretty difficult. I know we had some people in Florida who were sort of dealing with that same thing, and I've done some data collection in Iowa where it was kind of similar, where you've got these puffy clouds floating everywhere, and you're just basically trying to find a moment in time where like the field is not covered, and then you try to get your 30 or 40 minute mission in that time period. But it's tough. Like if the shadows are really extreme, it's really hard to remove those. The downwelling light sensors help, but they're definitely not 100% solution yet.
Right.
And from the analysis and post calibration side of things, it's slightly more time consuming, but if you can find invariant targets within your scenes that were nicely illuminated at the beginning of the flight, you can then begin to kind of calibrate based off of those invariant targets going through the flight, but you have to go scene by scene. There's several different methods that you can do, but yeah, it is a very difficult problem to get a nice, depending on what you want to do at the end, whether it's a nice orthomosaic you're looking for, or if you're looking to really maintain the spectra within the imagery, it's definitely a difficult problem to have. But we can, once again, if you email or follow up with us, we can help.
Great. Another question, which I think probably is addressed to both of you, is there any progress with drone imaging in forests? And can I have some work of Austin Coates on forest biomass? So he's looking for some of your research work. Drew, do you have experience with customers using drones and your sensors in forestry?
Yeah, we do. I don't know exactly how many are using it, but there are a number of customers who are using it for forest analysis. We did a case study on mistletoe infestations in an oak grove, I think, and it was, some of the composites we had were very effective at distinguishing one plant species from another. And I think that's something that's going on in Alaska too, if I remember correctly. There's an organization up there who's basically distinguishing different plant species from one another and kind of getting sort of an inventory of what's growing up there. But other than more details than that, I don't have a lot, but I just know it is being utilized for forest analysis.
Yeah, so the work that I did with forest biomass, we were using LiDAR sensors and then kind of merging that with optical sensors as well. These were flown on large aircraft over the forest. It was in support of a couple of other research projects that were going on. I'm not quite sure if it's all been published yet, but once again, if you can email me, I can follow up with you and get you some more information.
Great. Here's a great question. You mentioned this was an end-to-end solution. What about delivery of processed imagery to clients, especially in convenient web-based platforms that they can interact with? My understanding is that the final products are desktop-based in the ENVI program, if not web-based platforms for distribution of imagery to clients. Are there report export options to save as PDF or other shareable formats within ENVI? So I think this is a great question because it leads nicely into today we focused on the workflow on the desktop, but we do also have web-based enterprise tools. So all of the ENVI analytics are deployable in a cloud environment. And so you could easily set up a system where you could actually have these reports delivered through the cloud or web-based solution. And I'll let Austin answer the PDF and other shareable formats from within ENVI.
Yeah, ENVI can write out in multiple different formats. From what I showed today, you can output, so if you just wanted to output a plot, you could do that in tabular format or in a raster format, so as an image. You can also, all of those maps that I showed, you can produce those as, say, a PDF or a JPEG or whatever you'd like. You can also save them off as vector formats as well, so we write out to shapefile so that you can ingest them in other software packages or display them easily in a web browser. Yeah, we've done a lot of work on the back end for people, so imagery will come in, we'll process it, and then we'll put kind of web browser ready images in a folder in which they can serve up on their website. So we've kind of been the power behind it. Yeah, there's a whole host of different ways in which you can get the results onto a website.
Great. We have a question. How can I purchase the Precision Pass software? Does it come together with ENVI? Precision Pass is Austin's product. I'll let him talk about how it's packaged.
Yeah, so Precision Pass can be bought directly through us. It doesn't need ENVI or IDL. It is a standalone product, so you don't have to have anything else supporting it. It's a subscription-based product. So yeah, you can come to our website, harrisgeospatial.com, and find out more about it. So, yeah.
Great. Question, can we process with Pix4D and then send to ENVI like we can with MicaSense Atlas currently?
Yes, very much so. ENVI is data agnostic, so we can take in any kind of data format that you want to pass to us, or almost any, but yeah. Yes, very much so. If you want to process with Pix4D and then send the orthomosaic into ENVI, we are more than happy to use that.
Okay. We'll keep going. We've got 5 more minutes. Where can I get the equations for all the different indices, example, GCI or NDRE?
So if you go to, once again, if you go to harrisgeospatial.com, on there we have references to our documentation. So ENVI has very extensive documentation, and so does ENVI Crop Science. So you can go there, and if you look for spectral indices, we list every index that we use, or index that we use, and then all of the seminal papers that they came from, as well as the equations.
Yeah, we'll try and capture that and send a link out to the person that asked the question. That's great. What would be the best height to fly using MicaSense RedEdge? One for you, Drew.
Most people fly at 400 feet, and the reason for doing that is just to limit the amount of data collected. And typically, so that's capturing spatial resolution of about 8 centimeters per pixel. And for most uses, that's definitely good enough spatial resolution. So 400 feet is the maximum you can fly. That's typically what people fly. But if you have higher standards for spatial resolution, like let's say you want 4 centimeters per pixel instead, then you probably drop it down below 200 feet.
Great. Can I connect the integrated GPS of the DJI Inspire 1 with the GPS of the RedEdge?
Not that I'm aware of. There is a way for you to send a GPS signal to the camera from the aircraft, but I don't know specifically if the Inspire 1 has that capability.
Okay, we'll research that offline and get back to you.
Yep.
MicaSense suggests taking 2 images of spectral panel before and after flight. So during the large area mapping with multi-copter drones may take 2 or more hours. So which image of the panel do you use and how would you decide?
Mm-hmm. Yeah, that's a tricky question. So when we were processing data in Atlas, we had the capability of using both panel shots before and after. But a lot of processing solutions now ask for 1. And so we have the stance where we just recommend that you need to pick whichever panel is more representative of the lighting conditions for that day.
Okay, great. Does MicaSense or ENVI offer any object-oriented tool for plant counting? I think we can put this one to you, Austin.
Yeah, so ENVI Crop Science has a stand counting, plant counting tool in it. The inputs for it are kind of the diameter of plant that you're looking for, and yeah, that's about it. And then the output is either a raster representation, so you can just physically see where the plants live. It will also give you the diameter of the plant, and then you can also save it off as a shapefile if you're so inclined. That then can be passed into the other portions of the software too, so you can run statistics on each individual plant to find out any kind of information that you want to know about that plant. So if you wanted to run some sort of vegetation index and then find the plant health at that specific location, you can do that.
Okay. Then we have, what GIS or image processing software would you use for data processing afterwards once an orthomosaic is created with calibrated reflection values? Well, this is and obviously a biased answer, but we focused in on ENVI. It's a wonderful image processing tool, and especially with the ENVI Crop Science tool, really is leading the way as far as the remote sensing software is concerned. With regards to GIS, we are a platinum partner with Esri, and we have our tools very tightly integrated, so it's incredibly easy to take your analysis and export that out directly into the Esri tool set as well. So that would be my answer on that one. Did you have anything to add?
No, I agree. Yeah.
Perfect. Okay. All right. My watch is telling me it's close to 9 o'clock, so we will ask one last question. I'm sorry, there's a few that are not getting to. What type of spectral panels are provided with the MicaSense RedEdge? And do you have any recommendation how to use correctly for spectral panels for spectral calibration? So one for you, Drew.
Yeah, so the panel, we provide a panel with our camera. I don't know the details around, I guess the scientific accuracy of those panels, but I do know that sometimes people who are looking for a higher grade panel will go to a company that makes a specific panel that has like a higher standard than our panel. But it seems that the majority of our customers are find the calibration panel that we include with the RedEdge to be satisfactory for their applications.
All right, well, thank you. Two final questions. One, what experience do we have with, where is that one gone? Any experience with tobacco farming? Austin.
Yeah, we've done things inside of factories before. So as far as looking at the spectra of the individual plants and determining different characteristics, and then as well as things in the field too, kind of trying to help boost yield. So yes.
Great. And a quick one for you, I think it's a quick one, Drew. What are the main differences between the RedEdge and the RedEdge M cameras?
So they're pretty similar in terms of data. I mean, they're exactly the same in terms of data output. The imagers and the lenses on the RedEdge versus the RedEdge M are the same. The file outputs are the same. The difference is that it's a smaller size, so it's the volume of the camera is smaller, and also the weight. I think it's about 6 grams lighter. And then another thing is the backplate is aluminum versus a carbon fiber backplate on the RedEdge, so it allows for even better heat dissipation during operation. And then there's a wider window of power reception. So I think it's like 4 volts to 16 volts versus the RedEdge original was very strict on the voltage requirement. But it has a lower price too. Everybody likes that about it.
Okay, well, unfortunately, we're out of time. Thank you, everybody, for all the wonderful questions. We're sorry if we haven't got to yours, but we will follow up to all the questions after the webinar. This has been a really great interactive process. Drew, thank you for joining us. And also, Austin, thank you for taking the time to present today. As I say, we will be making sure that we follow up to this webinar. As you leave the webinar today, there will be a short survey, so please do take just 2 minutes of your time to complete it. It helps us improve our webinars. And tomorrow, we will send you out the links to these slides, the recording of the presentation, and additional information on the products that we showcased today in the webinar. We'll have a couple of case studies from MicaSense, and we'll have some product materials on the ENVI product range. So again, thank you everyone. It's been a great webinar, and we wish you well for the rest of your day. Thank you.